Okay, so let's move on to our second question. So, how does or why does the cellular system look like as of today? So, cellular radio system is actually your mobile phone and communication system that you use almost every day. So, we can't live without our mobile phone or a smartphone. So, sino ba naman ngayon ang walang phone or smartphone? Kumbaga siya ay parang kasama na sa everyday living. So, you'll see that your base station is in top of some building or on the street. Question is, where does your signal go when it goes to the base station, and through the base station, where does the final destination of signal will be? That is the question. But before that, why do we have such base station? How the system look like today? That is actually the key of the question. So, with in other words, there are two things that can be trade off each other. So one is connectivity and the other one is interferences. So if you look at this first photo, there is a graph and the nodes are actually connected. We see that actually almost every node is connected. So connection is very high but will generate a lot of interferences kasi imagine gaano kadami yung connection na yan. So there will be a lot of interferences. So perhaps no one can communicate due to the huge amount of interferences, but this is the case of over-connected cases. And on the other hand, on the left picture, we can see only few of them are connected. You can see the interface level will be very small. So in the end, this few connection will be successfully communicating in the end of each other. So, but however, the problem is that the less connected network, the capacity will not be that much higher. So, as per system designer, syempre yung ating mga engineer, system designer, so their goal is to have a reasonable amount of or optimize the number of successful communication pairs or maximize the capacity wires network by having fine density or by having the optimal transmitting node density. So, from radio resource management perspective, by having the optimal connectivity density, we could have maximize the capacity. Means actually we can control node density in particular to transmission node density. Well, the problem is that even though we have a good media access control, nandiyan na lahat ng kailangan, yung desire to communicate by people is increasing. Siyempre, as per araw-araw, laging merong bumibili ng bagong phone, merong bumibili ng bagong uh, tool for communication. So because we understand that every day actually people try to use smartphones more and more, so there is actually the contradictory type of situation here. So we can now support large number of users simultaneously due to the huge amount of interfaces while their demands are increasing. So the question is, how do we handle this particular situation na nag increase yung capacity and also nag increase din yung demand doon sa kailangan kumonect doon sa base station. So, paano natin i-handle yung ganitong situation? So, the big problem is that how can we support the increased number of communication pairs while minimizing interference level acceptable? Okay. So, this should be done through the help of the neonatal design or neo-architecture design. So far, we have been assuming that every communication link is based on wireless connection generating interferences. So, however, we could replace some of the wireless connection by wireline in communications. That means we can construct the hybrid of wired and wireless links. So question is which part should be replaced by wire links and which part uh, will be supported by wireless links. So to answer the questions, I think it's better to introduce the networks which is called a spoke and hub network. So spoke and hub network looks like this. So in a spoke and hub network, some connections are locally done and they are connected to some hub nodes. Well, we can find this spoke and hub network, for example, in the airline traffic network. So, yan yung gagamitin nating example para mas madali nyo ma-visualize kung ano nga ba yung or kung paano gumagana yung spoke and hub network. So, you travel from one city to another. So, for example, galing tayo ng Batangas City. So, ang pinakauna natin gagawin para, for example, ang destination natin is Bohol. So, ang pinaka natin gagawin is we will take local transportation. So, from Batangas City, for example, sakay ka ng bus or sakay ka ng bus punta ng Manila. So, your local airline, pero local pa din naman, local trip pa din siya. So, magsimula muna tayo dito. Local airline to local hub airport. So, from that hub airport, then you can transit to the international big, huge airplane. So, for example, kunwari ako, kasi as per my experience, punta kami ng Myanmar. So, from here, from Batangas City, punta muna na Naiya. Then, from Naiya, meron kami, hindi ko na matandaan, basta meron kaming pinagpuntahan uli na isang hub airport. Then from there, may sinakyan pa kami na isang flight para makapunta kami to Myanmar. So, yun yung concept ni Spoke and Hub Network. So, from your local area, papunta doon sa mas, kumbaga international or yung bigger, bigger space or mas mataas na level nung iyong communication. So, yun yung pinaka-concept ni Spoke and Hub Network. So, this is actually the so-called cellular radio communication. So, for example, the wireless network hub is a spoke that is based on wireless connections. So, for example, each spoke is connected to the local hub. That is actually the base stage, and each node connected to the hub is your mobile terminal, and each node will be communicating to its nearest base stations through wireless connection. And then between them is the hub node, or between the base station, they are already connected to the wireless link, are the so-called backbone network. So the local connection is done by wireless link with a small transmission power, and then the connection between access point or hubs are through wired link, which is actually the long distance kind of communication. So by using such wired link, we could reduce the amount of interference that is generated by the original wireless connection. So by doing this, we could remove the wired interface. Okay, so dahil nga nagkaroon tayo ng spoke and hub, magkakaroon tayo ngayon ng connection locally, wireless, and doon naman sa mga malalayong connection, so gagamitin naman natin doon is yung ating wired connection. So, this is the actual transport capacity. So, the transport capacity means the bits multiply by meter. So, as n goes to infinity, that means as user goes infinity, transport capacity along will be decreasing. Well, you can decrease, for example, amount of bits or travel distance. So, if you want to keep the current bits, for example, what you can do is bawasan natin yung distance between the transmitter and receiver. And the radio system is just following such rules. Okay. So, kung gusto mong increase yung iyong data na ipapasok or QQ, so kailangan ang gawin mo para mas mabilis siya makarating doon is bawasan yung distance between doon sa iyong transmitter and the receiver. So, yun yung radio system na fina-follow or yun yung rules na fina-follow ng radio system. So, as number of nodes increasing or as the number of mobile terminal is increasing, what they do is they do not decrease the data rate or bits. Instead, they decrease the meters. That means the distance between the mobile phone and the base stations. That's why kung mapapansin nyo, merong mga base station na malapit sa inyo kasi hindi pwedeng bawasan yung data rate or yung bits. That's why ang binabawasan nila is yung distance between dun sa transmitter and doon sa receiver. So, what we can understand is that as number of users will be increasing, the distance between your mobile terminal and base station will be shrinking. Kaya dumadami na dumadami yung base station natin kasi dumadami yung uh, user natin. So, kagaya ng sinasabi dito, so as number of user is increasing, the number or the distance between the receiver and the transmitter is shrinking. Okay. So, but anyway, by using this spoke and hub network, we can see how the interface can be reduced to support as many users as possible. Kasi nga, kumbaga, nagkakaroon ng flow yung iyong transmission ng iyong data papunta dun sa receiver. So this shows the very fundamental pictures of the cellular radio network of today, the 2G, second generation, 3G, 4G, and 5G as of the moment. So you see on top of it, there are mobile terminal. In between, there are base stations or eNote T in LTE system or access point and that Wi-Fi system, for example. So, and in each node will first connect to their nearby base station. So, ito yung nearby base station through the wireless link with a smaller power. Kasi mas malapit siya sa base station, mas less power at hindi nababawasan yung data na ipinapasok. Kasi malapit lang naman yung iyong distance doon sa base station. And then each base station will deliver your signal to your partner, business mobile phone through the nearest base station. And each base station is connected by the cellular core network, which is actually based on wireline network. And of course, this wireline network base station, one network is also connected to the internet network. So you can also use internet through this architecture of cellular radio networks. Well, in the satellite of radio systems, or number of cells or number of base station are quite important to the capacity of the system or a network. So our next question will be, does increasing the cells increases the capacity?